In this nugget, you and I get to take a look at MACsec as well as Cisco's TrustSec technologies. Let's begin. I'd like you to imagine that you and I have been asked by our boss to protect this little segment, this little leg of our journey between a PC and the physical switch. And fortunately, one of the options we have to protect that little segment of traffic is called MACsec, which stands for Media Access Control Security. And with MACsec, we can actually negotiate and set up confidentiality through encryption using AES, as well as data integrity by using something called an integrity check value in each and every one of the frames. Now, one of our challenges is this. If we're going to do the data encryption and the verification of layer 2 frames, we're going to need to negotiate some secret keys that we can use for the encryption and for the data integrity. So for a PC or a host, as it connects to a switch, if we're using MACsec, we're going to use something called the MACsec key agreement to establish shared secret keys that we can use for those purposes. In addition, we are going to use a different frame type than our traditional Ethernet. Our frame is going to have a brand new 802.1ae header. It's going to have a new field available for vendor-specific implementation. In the case of Cisco, we're going to put some security group tag information there. We'll talk about that in just a moment when we focus on TrustSec. And there's also a field for ICV. That's the integrity check value, so that as a frame comes in, the switch can look at that frame, and if the ICV value isn't correct for the frame, it can discard it. Doesn't have to process it any further. Now, MACsec can be extended further than just between a host, for example, this PC, and the switch that it's connected to protect this segment. If we also wanted to protect the path between switch 1 and switch 2, we could do that as well, but the important thing to be aware of with MACsec is that it is hop by hop encryption. In a traditional VPN, we might have a PC that's going through a large network, and using a virtual private network, we'd have one encryption that's done here at the PC and another decryption that's done right here at the final destination. With MACsec, the encryption is done hop by hop. So this host would encrypt it and the switch would decrypt it. And if switch 1 and switch 2 had negotiated and established MACsec between them, switch 1 would re-encrypt and switch 2 would de-encrypt. So between two switches that are going to be using MACsec, it would be SAP that's being used to negotiate the security keys that these two switches would use with each other. So between the host and the switch, it would be the MACsec key agreement, and between switch 1 and switch 2, they would be using SAP for the negotiation and establishment of the keys that they're going to use with MACsec. So when configuring switch-to-switch MACsec, that could be either a manual process where we manually configure the details on each of the switches for MACsec, or if we're using some type of a centralized server such as ICE, the MACsec between switch 1 and switch 2 could be dynamically negotiated. Now, one of the cool things that Cisco has done is they've taken IEEE 802.1ae that has these additional fields, and they said, how could we leverage that to increase the security posture and make it easier to manage large environments? And one of the things they did, they created the concept of TrustSec. It's a Cisco concept where a group of devices, and they're all paying attention to various labels that have been associated with frames of data. And that label would be right here. It's the SGT value. SGT is an acronym for Security Group Tag. So, for example, you could have security group tags that represented departments like sales, human resources, engineering, development. And so maybe we've assigned sales a number of 1, and HR is 2, and engineering is 3, and development is 4. So all by themselves, these labels, these SGT values, are just numbers inside of the frames. However, what we could do is we could set up rules based on those labels. For example, we could say deny packets that have a security group tag of 1 if they're trying to use specific protocols destined for security tag number 2. And those rules could then be deployed on things such as iOS routers that understand those rules. And they could be implemented as security group access control lists. And once set up as part of a TrustSec domain, this gives us a single place to control access instead of having to manually visit routers and firewalls and switches to change our security policies. Because we could push these types of policies down from a centralized management system like Identity Services Engine. Now, one of the challenges that we're going to have in our environments is that not every single device is TrustSec capable, meaning it doesn't have the hardware to process and understand those SGT values, those labels. So to address that in a Cisco TrustSec domain, we can use the SGT Exchange Protocol. And the acronym for that is SXP for SGT, that's the Tags Exchange Protocol. And I like to think of it like DNS for security group tags. I mean, let's think about it. How do we use DNS today? Well, we try to go to google.com. That gets resolved to an IP address. Now we know that IP address and we can act on it. With SXP, we can have, for example, ACS or ICE inform our devices that can't in hardware process those labels directly. Let's say, for example, we have a firewall that needs to enforce policy but doesn't know how to read those labels. Using SXP, one of these AAA servers could then inform the firewall regarding the IP address to SGT mappings. So the firewall, for example, could still have the information regarding deny group 1 to group 2, and then with the SGT mappings, it would know, okay, subnet 40 is equivalent to label 1, and subnet 50 is equivalent to label 2. And then it could logically swap that information in to the security group access control list that it's using for proper filtering of that traffic. So even on devices like this firewall that doesn't have the ability on its own to directly process an SGT, a tag, it can still implement security group access control lists based on those tags because it now has the mapping that it learned of IP address to group tags through SXP. In this nugget, you and I have taken a look at how to protect both the confidentiality and data integrity on a hop-by-hop, a link-by-link basis using MACsec, including some additional fields that are available in the 802.1ae frame that makes that possible. We've also identified that in a Cisco environment, by using a TrustSec domain, we can leverage the security tag information and then based on those tags, implement security group ACLs. And for devices that don't directly in hardware have the ability to read those frames, we can pass on the information regarding the labels or the tags and the associated IP addresses associated with those labels using the SGT Exchange Protocol. I have had a great time in this nugget. I'm glad you joined me for it. I hope this has been informative for you, and I'd like to thank you for viewing.